first thing we need to look at your syllabus one by one. Sometimes the textbook, I don't have it on this system. I think I have it in my old system. I will sort it out. I can put it on, I can send it, I will put it where you will find it, maybe on the classroom where you can download it. I'll just send a link to you where you can use to download it. Is that okay?
All right.
So we have, so you have that today. I should be able to do it today. Before the runs, you need to do it today. Place on the classroom and you can download it and you have it yourself. Is that okay? So we have 8 topics in physical chemistry. So we are starting with the first one because these topics here, these topics in physical, these ones, they are fundamental topics. They are found in other topics. So they are the primary. After taking the physical chemistry, I can choose to go to inorganic or organic, depending on what you want. But physical chemistry must come first. Is that okay? Yes. So I'm taking it, I'll open the syllabus now. So there are 2 things you need to have. Number 1, apart from the test, we need the syllabus. This syllabus is for 2025-2027 students. So you need to look at it for 2025, 26, 27 exams. Is that okay? You need a syllabus. Number 2, you need a data booklet. Data booklet are contain constant that will be given during the exam. For example, now look at it now from here. You can see now molar gas constant, Faraday constant, Avogadro constant, all those stuff, mass of proton, neutron, and electron. Then again, you talk about ionization energies. They will ask when we come to that, we'll do it on this topic now. So I'll teach how to use this table. Then again, you have bond energy values is there. Then finally, you also have periodic table. There are many other values that you have periodic table at the back. So you're supposed to have a copy of this. So I'll put these 2 syllabus and the data booklet on the classroom. You can download it from. Is that okay? Yes, so let's start the work for the first topic according to the syllabus here. Oh, there's stop sharing. Oh, I'm sorry for stop sharing. I have to share again. Sorry for that. Okay, what's going on? Can you see my screen back?
Yes, sir.
Okay, thank you. Now, so the first topic is atomic structure. I have a note on that. I don't have notes on every topic. I have a note at least more than maybe 2/3 of the topic. Okay. I have note on at least 2/3 of the topic. The one I don't have note on, I'm just the forming note for you. As I may just the, if I can try to guide the note, most of the notes they put online, some of them are not updated. If you want to update one, you have to pay. So they are based on the old syllabus. But this one is based on the new syllabus. Is that okay? So let's see. The first topic here is atomic structure. So what is that you learn from a syllabus? You open this the topic, they are learning outcome. The way the IGCSE syllabus is designed, the same way A-level is designed. If you see the learning outcome, that at the end of, look at this first topic, atomic structure. He said atomic structure, particles in atom and atomic radius. You know that this one may not, you may not understand this one fully, but this one you should know this too in IGCSE. Am I right? So let's start. Yes. Number 1, what are we to learn? Understand that atoms are mostly empty space, surrounded by what? Excuse me. Let's take this off. It's not going up. Okay, how do I take this off? Okay, no problem. Surrounded by what? By a small, dense nucleus that contains proton and neutron. Electrons are found in the shell in the empty space around the nucleus. Let me draw a diagram for you. The note is here, but I have to see write 1 or 2 things for you as I'm teaching you now. Okay, good. I will do it. Thank God. Good. So now atomic structure. Let me write with black. Topic 1, that is atomic structure. If this is an atom, nucleus is this. The atom is so big compared to nucleus. If the mass of the whole atom, let's say the mass of this whole atom, the mass, atomic mass, we call it mass of atom. Suppose atomic mass, suppose it is 8.0000 grams. Then the mass of this tiny nucleus is about 7.9994 grams. Can you imagine? What does this imply? The mass of the nucleus, this guy is a nucleus. Is it not the nucleus? This guy is a nucleus. Am I right? The guy in the center. The nuclear, so we are saying that, remember atoms, let me write in single one. Then you note I'm just saying the atom contain nucleus and the shell, which house the electron. Electrons are located on the shell, right? Nucleus now contain what? Protons and what? And neutrons. We are saying that the mass of nucleus is almost equal to the mass of the atom. What does that imply in terms of mass for electron? We are saying that atomic mass is approximately equal to what? Nuclear mass. The mass of what's inside the atom class? Proton, neutron, electron. Almost equal to what? Proton and neutron. Do you understand what that means? Nuclear mass is the mass of the nucleus. Nucleus contain proton and neutron. We are saying that the mass of proton plus neutron plus electron is almost equal to the mass of proton and neutron. What does that imply for electron? If you said, let me look at it. You said x plus y plus z is approximately equal to what? X plus y. What is z? What can you say the value of z is? X plus y plus z is almost equal to x plus y. Can you suggest a value for z?
0.
Exactly, 0.
Yes.
Z is almost useless. So what are you saying? So now come back here and tell me, what does that mean for electron? The mass of electron is almost 0. Electron has almost no mass. So electron has negligible mass. Almost the entire mass of the atom is located inside the tiny nucleus. Is that okay?
Yes.
Almost the entire mass of the atom is located inside the tiny nucleus. Electron have what? Negligible mass. That tells us. Is that okay? Now I put in the note. Come and see the note. Now can you read this? Can you read? I want to explain to you. Can you read?
A description of subatomic particles. From data booklet, MP is equal to mass of protons is equal to mass of neutrons, which is equal to 1.67 times 10 to the power negative 27 kg. Mass of electron is equal to 9.11 times 10 to the power negative 31 kg. Also, electronic charge, which is equal to the magnitude but opposite.
Equal in magnitude. Equal in magnitude.
Equal in magnitude but opposite in
sign.
To that of a protein. Is that a negative?
Yeah, electron is minus 1.60 10 to power minus 19. What will proton now be? Plus 1.60 10 to power minus 19. We are saying that proton and electron have the same value, right? But they have opposite sign. Do you get the point now? When you now compare them relatively, comparing to each other, since proton and electron have the same charge, we can say proton is plus 1, electron is plus minus 1. Do you agree?
Yes.
The actual charge of a single electron is this. It's not minus 1. This is the actual charge of one electron. The actual charge of electron is this. And the charge of the proton is now plus. So when you now compare the two of them, it is now plus 1, minus 1, relatively to each other. Is that okay? Now, proton is mass 1, because look at mass of proton. Mass of proton and neutron are the same thing. So compared to each other, if mass of proton is 1, the mass of neutron is also 1. How do we not get mass of electron? It will not be mass of electron, relative mass of electron will not be what? Will be 9.11 times 10 to the power minus 31 over 1.67 times 10 to the power minus 27. When you are comparing the mass of proton is our reference. Proton has a mass of 1. So is neutron. What's now the mass of electron compared to proton? It should not be mass of electron over proton, which should be what? 1 over 1836. This is electron, no, this is proton. So how many times is a proton heavier than electron?
Sorry?
How many times is a proton heavier than electron? When we did mass of electron over mass of proton, we got 1 over 1836. So how many times is a proton heavier than electron?
1,836.
Exactly, that's it. So proton is 1,086 times as heavy as electron. Do you get the point now? Therefore,
Yes.
when proton is 1, electron is 1 over 1836. Now,
Mm-hmm.
let me ask you this now. What if you say proton has a mass of 1836? What will the mass of electron be?
1.
On exactly 1. Can you answer now? So proton is
Mm-hmm.
1,836 times as heavy compared to what? An electron. Is that okay? So electron have almost what? No mass, almost no mass. So we can say that's why they said the first point says that. Look at it said, we have to understand that atom consists mostly of empty space surrounded by a very small but dense nucleus that contains proton and neutron. Electrons are found in the shell in empty space around the nucleus. Almost, I'll add now that almost the entire mass of the atom is located in the nucleus. Now, let me explain that to you. Let's say your whole body is atom. Let's say your whole body is one atom. You go and check your mass. Maybe you weigh, let's say you weigh 60 kg, 60 kilogram.
Mm-hmm.
You now go and shave your hair. Shave your hair. Go and weigh again. What will you weigh? The way you are, you climb a balance. Your mass was
Mm-hmm.
60 kilograms. You now go and shave your hair. You go and cut your hair. Go and weigh again. What will you weigh?
You said 60 kilograms?
Yes, you weigh 60 kilograms initially. You
Yes.
now go and cut your hair. You go and weigh again. What will you weigh?
60.
Exactly, because your mass, the half your mass, the
Mm-hmm.
mass of your hair is up to 1 kilogram. Do you agree? So you
Mm-hmm.
say weigh 60. So let's just say your whole mass is proton and neutron. I mean, your whole body, complete
Mm-hmm.
from head to toe, is atom. But your body without your hair is proton and neutron only.
Mm-hmm.
Therefore, electron has a mass, but the mass is so small compared to proton and neutron. So the mass is what? Negligible. So if they ask you
Mm-hmm.
question 1, which of the atomic particles contribute to atomic mass? Which was the answer?
Proton and neutron.
Exactly. Now, number 2, which of them is neutral? Which of them is charged?
Neutral is neutron, and then proton is charged.
And the electron is also in charge. Do you agree?
Negative charge,
Electron is also
yes.
charged. So we are done with the first point. Like I said, the notes are here. Look at the notes are here. Look at it now. Look at the neutron is neutral. They are here. Do you get now? Point 2 says, it says identify the proton and neutron by their relative charge and masses. We've done that. That's the table I show you now, right? The table. This table is that okay? Proton relatively is the actual mass of proton is 1.67 10 per minus 20. Says in your data booklet, they give you a copy during the exam. You don't have to memorize it. But when
Okay.
you compare proton and neutron, they have the same mass. Electron is now very small compared to them. Is that okay? Point 3 says, can you read number 3?
Understand the terms atomic and proton number, mass, and nucleon number.
Thank you. I'm sure you must have heard about that before.
Mm-hmm.
That's point 3. I'll be writing 3 so you can compare them. When you write an element like this, element X, element A, right? Yeah, element A, X, and Y. Is that okay? This,
Mm-hmm.
what does A represent? The symbol of the element, right?
Yes.
What does X represent? The number on top. We call it
Uh,
mass number, or some call it atomic mass. Some call it nuclear number. All the 3, any of them can be used. But get used to all the 3 of them. Any of them can be used for you.
okay.
Wow. Hey, what happened? Hold on, please. My pen. Just hold on. Okay. Okay, good. It's working. That's good. They use mass number, nuclear number. These are the 2 ones they use mostly for it. For your, sometimes they call it atomic mass. The same thing. Mass of atomic mass. What about Y? Atomic number. Or what? Proton number. Do you agree?
Yes.
Now, X represent what? Proton and neutron. What about Y? What does Y represent? Proton only. Now, for a neutral atom, when the atom has not lost electron, it hasn't gained electron, then Y is also electron number. Do you agree?
Mm-hmm.
For an atom is electrically neutral. What that means, the atom contains equal number of protons and electrons. If it has not lost, if it has not gained, is that okay? So here
Mm-hmm.
now, in this element now, if I give you this one and look at this element, if I give you this now, I said 32. Let me use 34 for sulfur. Sulfur can be 32 or 34. 32, 16, S2 minus. 32, 16, S plus. 30, 33, 16, S2, S. Now let's work it out for all of these guys.
Okay.
So let's work out their proton, neutron, electron. Yeah, let's go. Proton for all of them. They are all 16, 16, 16. What about neutron? 18, 16, 17. Now electron, Go on, work it for me. Electron.
So it will be 16 plus 2,
That'll be
18.
18. Thank you.
17.
What about this? Are you sure?
It's 15. It lost 1.
It has lost 1. 15. And this one
16
remaining
neutral.
was 16. Do you get now? So you can work it out. Is that okay? You said you need to work out. You should know what atomic mass number and atomic number, and you need to work it out. That's what the third point says. So we have just given one example. I'll be posting topical questions for you. There are many. If you can sit down and solve them, you're already securing your A star now. A star is not when exam is 2 weeks ago. It doesn't work that way. A star go from the first day. So then I'll post topical question for you. Theory and multiple choice. I'll post the mass scheme alongside. Now, when you are solving them, you don't use mass scheme. When you are done with your answer, then go and now mark yourself. As you're marking yourself, there are some answers you now say, oh, I realized my mistake. I got it. Oh, there are some that you say, I know I don't agree with this answer. No, like. You must argue with the mass scheme. If not, you are memorizing it. You don't argue the mass scheme. You just say, oh, mass scheme say this is the answer, and therefore that must be the answer. I cannot reason it that why it was the answer. Then you are not helping yourself. If truly you are reading, you must be asking questions all the time because you couldn't have understood everything you read. Do you get the point now? That's the logic for this exam. Do you understand? We'll get there. Now, number 3, we are on number 4. Can you read number 4, please?
Describe the distribution of mass and charge within an atom.
Now, I'm giving you. Now, yeah, let's do mass and that. Yeah. Can you read, please? Can you read, please?
The distribution of mass and charge within an atom. Almost the entire mass of the atom is located inside the nucleus. That is, mass of the atom is contributed majorly by the nucleons. The components.
What does nucleons mean? Nucleons are the word proton and neutron. Nucleons means proton and neutron. Please know that. Okay. Nucleons means proton and what? Neutron. And neutron. Is that okay?
Yes, sir.
Good. Yeah, go on.
The components of the nucleus. Electrons have negligible mass.
Good.
An atom is, it says an atom is
electrically
neutral since the total positive charges, that's the proton number, equals the total negative charge, the electrons.
Okay.
The nucleus of an atom is positively charged because of the presence of protons. Hence, proton number also means nuclear charge.
Do you understand what that means? When we say nuclear charge, the charge on the nucleus is due to the presence of what?
The proton.
Of proton. When we say nuclear charge, we mean proton number. Do you get the point now? When we say nuclear charge, we mean proton number. Is that okay? So question 1, what's the charge of an atom?
Positive, plus.
What is the charge of an atom?
The charge of an atom.
Neutral.
Oh, it's neutrally charged because of protons and electrons. Okay.
They have, you call it, contains equal number of proton and electron, right? Yes. What is the charge of the nucleus? Positive or negative or neutral? Nucleus.
The nucleus, it's neutral. Oh, no, it has protons, so it's positive.
Thank you.
Yes.
So, what about the charge outside the nucleus?
Outside the nucleus, it has electrons. That's negative.
Thank you. Do you get the point now? So an atom is neutral overall, but the nucleus is positive. Outside any other part apart from the nucleus is what? Is negative. But total positive inside the nucleus equals total negative outside the nucleus. Therefore, the entire atom is what? Electrically neutral. Does that make any sense?
Yes, that makes sense.
So when I say nuclear charge, what does that mean? Proton number. because the
Mm-hmm.
charge on the nucleus is because of the proton that is there, right? So
Mm-hmm.
nuclear charge means proton number. I'm sure that makes sense.
Yes,
Now,
yes.
go on, please. Go on. When an atom, next one,
When
when an atom,
when an atom loses or gains electrons, it is no longer neutral. An atom which has gained or lost electrons and hence possesses an overall charge is called an ion.
does that make any sense?
Mm-hmm.
So give me the name of this ion. Tell me, give me their name. Call them for me. Start from magnesium.
Magnesium,
No,
magnesium.
ion. Can you say magnesium ion?
Uh,
No,
yes,
it's supposed to be, you don't say, just the answer is magnesium ion because Mg is magnesium atom.
okay.
Mg2 plus magnesium ion. You can't just say magnesium. It should not be correct. You must tell me what are you referring to? Is it an atom or what?
Ion. Okay.
Magnesium ion. What about the next one?
Is that fluorine ion?
Yes. No, it's called fluoride ion. Fluoride.
Fluoride ion.
Exactly. Fluoride ion. Fluoride ion. Go on, please.
Aluminium ion
That's correct.
and oxygen ion.
Oh, it's not called oxygen ion.
Oxide ion.
And
Oxide.
I guys now, I will not tell you some. You figure them out yourself. It's called oxide ion.
Yes.
All those non-metal, they end with "ide." So listen very well. Hydride, hydrogen minus is hydride ion. Now let's go on. Carbon is carbide ion, nitride ion, oxide ion, fluoride ion, chloride ion, bromide ion, iodide. Can you see now? They end with IDE. But for metal,
Mm-hmm.
they just maintain that name, just put ion. Sodium ion, potassium ion, copper ion. Those one don't change their name. They just add ion to their name. Do you get the point now? So this
Yes.
fluoride ion, this is what? Oxide ion, oxide ion, oxide
Oxide.
ion. But this one is magnesium ion. It doesn't change its name. Magnesium ion. Is that okay? Let me
Yes.
make it smaller. I have magnesium ion, fluoride ion,
Aluminium
oxide ion. Then this one, of course, is aluminum. It doesn't change its name. Aluminium
ion.
ion. Does that make any sense?
Yes, it
I'm
does.
saying that, so the metal don't change their name, but the non-metal, their name become IDE, ide, oxide, chloride, bromide, sulfide, phosphide, arsenide, selenide. Do you get it? The end with IDE, IDE. Does that make any sense?
Yes.
Now I put some, I've explained this to you already. How to find proton number. Am I right? We did it at that time. Am I right?
Mm-hmm.
Proton here, look at it now. Proton here is, proton here
13.
is 13. Electron is, because it's neutral, electron is also 13, but neutron is now 27 minus 13, which is 14.
14.
Am I right? But
Mm-hmm.
we now say when you gain here, look at this guy. How many protons does he have? Why?
Right.
Why? We don't know what why. Why is a number? Why proton? Do you agree?
Mm-hmm.
How many electron does he have?
That would be Y minus N.
That's correct because it has lost n number of electrons. How
Mm-hmm.
many neutrons? How many neutrons does he have? Neutrons. Neutrons.
X minus Y minus N. No?
Why are you connecting n to the n is for electron now? We don't
Oh,
lose
X minus
neutron, we don't
Y.
lose proton. Yes, we know why. We don't lose proton, we don't lose neutron. They are constant. The only thing
Oh,
we can lose is
okay.
electron. We can't lose anything other than electron. Do you get the point now?
Okay.
Now, do you get that now?
So you're saying even if it has gained or lost the neutron number, it remains the same.
Neutron does not change. Proton does not change. It's the electron that can change.
Okay.
Do you get the point?
Yes.
But you can have an atom that has different number of neutrons. What do you call this one? Like this one now. Maybe 34, 16 sulfur, 33, 16 sulfur, 32,
Isotopes.
16. Aha. They may have different number of neutrons, but they never lose neutron. They never
Okay.
gain proton. They never gain the only thing that can be lost or gained is electron. Why? The only thing that can be lost or gained is electron. Why? Can you tell me why?
Because it's outside the it's like outside the shell
No, it's on the shell. It's not outside the shell, it's on the shell.
in the shell.
So that's not the reason. The reason is that electrons are the one involved in chemical bonding.
Okay.
Protons are never involved. Neutrons are never involved. When you say two atoms are reacting, they are either sharing electron or losing and gaining electron. That's what they do. They don't lose proton, they don't share proton or neutron, they don't do those one. So electrons are the one involved in chemical bonding. Does that make any sense? So electron can be lost, can be gained, or can be shared. When we share electron, what kind of bonding is that?
When we share, it's covalent.
Covalent. Whereby when we lose or gain,
Starts with an I. Forgetting the name.
okay,
Ionic.
somebody ionic. That's you can hear now. So electrons are the one involved in chemical bonding. Electron can be lost, can be gained, can be shared. But proton and neutron don't change. Do you get it now?
Yes.
Thank you. Good. That's fine. So here now, so neutron here should be X minus Y. Is that okay? Good. What about this guy now? What about that guy? How many electrons does he have now?
Y plus M.
Because it has gained M. We don't know what M. M is a number. M can be anything. Is that okay? So when it carry negative, it has gained extra. Now, question 1. Okay, sorry, that's fine. That's fine. So look at oxygen. And now they can also do something like this. So look at this one. How do you do it? Let me write it down in the paper for you.
Okay.
Look at this. Carbonate. It says find the number of proton, neutron, electron. Let's go. You have to separate them one by one. Look at it. You become 12 6 carbon, 16 8 oxygen, overall charge, no, 3, 2 minus. Can you see now? How much I did? So how many proton is here now? Tell me. I'm not telling you. Work it out for me. How many proton is in CO3? Add them together.
6 plus 8.
6 plus 8 times 3. There are 3 oxygen there. That'll be 30. Do you agree?
You're saying times 8 times 3. Yes, I
Yes,
agree.
there are 3. Do you get? Now, what about neutron? You see the same thing. You see 6 in carbon. The 8
Plus.
times 3 is still 30.
Mm-hmm.
How many electrons are there? Don't count electrons. Just go and look at number of protons. How many protons are there? 30, right?
30.
So it has
Yes.
gained 2 extra, then 32. Simply that'll be 30 plus 2.
Yes.
That'll be 32.
32.
Do you get the point? That's how to calculate this?
Yes.
They give you some that are tricky. You don't let them question like this. Some that are very tricky. You must take your ground and don't let them confuse you. Now we have to do this. Yeah, look at this one. I'll give you this one. OH minus. How many protons? How many neutron? How many electrons? So you separate into what? 16, 8, 1, 1 each. Minus. How many proton?
So 9.
Neutron.
That's 9 plus 1. Neutron. That's 16 minus 8. And then 1 plus 1. No, 1 minus 1. So that's 8.
Now you're talking. Because there's no neutron in hydrogen. What about
Yes.
electron?
The electrons, it's 9 plus 1. 10.
These are no BJ question came in. He said, which of the following species contain different number of proton, neutron, and electron? That year the answer was OH minus. He said, which of the following species contain different number of proton, neutron, and electron? It was multiple choice. The answer was OH minus that year. Do you get the point now? So that's calculate that. That should not trouble you again. Now let's go back to our syllabus. So we are done with. So if I'm to tell you, if I'm to say it in word to me, tell me how can you describe the distribution of mass within an atom? Tell me how can you describe it? Say it in your own words. Distribution of mass within an atom. Almost the entire mass of atom is located inside the tiny nucleus. Do you get that? That's what that means.
Yes.
Almost the entire mass is located inside the tiny nucleus. Nucleus is so tiny, yet so heavy. In fact, in the whole universe, nucleus is the heaviest substance in the whole universe. There's nothing as heavy as nucleus. It's the truth. Because all substances are composed of atom. And we are seeing that atom consists of empty space. So the nucleus is the one that carries almost all the mass of that, and it's so tiny. Better you pack it together. Nucleus is going to have the greatest density in the whole universe. There's only as heavy as nucleus.
Okay.
There is no space in nucleus. Nucleus, all the nucleus, neutron, and proton, they are pumped together. Do you agree? There's no space between them. So the guy is so heavy, yet so tiny. Now, how do you find density? Density is what? Mass over volume. The guy is so massive, yet the size is so tiny. And density will be very, very high. Do you agree with that? Mass is very big. Then volume is so tiny, though you have a very great density. Is that okay? So you can say that for mass, almost the entire mass of the atom is located inside the nucleus. That's the division of mass. Proton and neutron are the one that contribute majorly to the atomic mass. Electron is almost negligible in mass. Is that settled? What about the division of charge? What about that of charge?
Inside the nucleus is positive, and
Because it
then
contain proton.
because of
Outside
protons, and then
nucleus is negative
outside
because
is
it contain
negative.
electron. But the whole
Yes.
atom is neutral. That's how to say it.
Yes.
Mention the 3.2. Nucleus is positive because it contain proton.
Mm-hmm.
Outside nucleus is negative, contain electron. But the whole
Mm-hmm.
atom is neutral because number of proton equals to number of electron. No story. Do you agree?
Yes.
Now let's go. Next one, number 5. Can you number 5?
Number 5, describe the behavior of beams of protons, neutrons, and electrons moving at the same velocity in an electric field.
Thank you. Yeah, come and see that here. My notes is that. Yeah. Can you read? Hold on. Can you read, please?
Behavior of subatomic particles in electric fields. Neutron is neutral, so it is undeflected.
Hold on, please. Hold on. This is positive plate of electric field, negative plate of electric field.
Okay.
Neutron does not just point on, it doesn't get attached to any of them. Say I'm neutral. I'm not telling both of you, I'm not interested. But electron that is negative goes towards the positive plate. Can you see now? Unlike charges attract. Proton that is positive goes towards the positive negative plate. Unlike charges attract. Is that okay? Does that make any sense? Electron is negative, it deflects towards the positive plate. Proton is positive, it deflects towards the negative plate. Neutron
Okay.
is neutral, it is undeflected. Is that okay? Does that make any sense?
Yes.
Now, which one now deflects more? Look at the extent of deflection of electron. Look at it.
Mhm.
Great. What about this? It's so small.
Small.
Why the difference? Why?
I
Why
would say
does electron deflect more than
electron
proton?
electron is less heavy, so it's easier to
Thank
move.
you. It's so tiny. When you throw, maybe you throw two stones with the same force, the lighter stone will go further than the heavier stone. Is that not common
Yes.
sense? That's
Yes.
what you're trying to say. So you just say electron is negatively charged, so it deflects towards the positive plate. It has a relatively small, greater deflection because of its small mass. Am I right?
Mm-hmm.
Proton deflects towards the negative plate because it's positively charged. The deflection is small because it is relatively heavier or has greater mass. Am I right?
Yes.
So that's all about that. You can go over that again. I'm going to the next
Mhm.
one. Now, next one, number
Number
6. Hmm.
Determine the numbers of protons, neutrons, and electrons present in both atoms and ions, given atomic or proton number, mass or nuclear number, and charge.
Have you done that or not? We've
Uh,
done that now. I'm like,
yes.
how to find proton. Now, I want to show you now what we call isoelectronic species. It comes out sometime in Cambridge.
Okay.
Now, look at this guy. Okay, yeah. They call
Yes.
it, look, what does the word iso mean? Similar. Give me a scientific word that start with, apart from isotope. Iso, have you heard of isomer before? Isomer.
Isom. Yes.
Isomers in organic chemistry.
Yes, I've heard about that.
Now, iso means similar. So isotopes means same proton but different neutron.
Mm.
Isomer means same formula but different structure. Now,
Mm-hmm.
isoelectronic means same number of electrons. Isoelectronic, same number of electrons. Now, look at this guy. Let's go. This guy, helium, how many electrons does he have? Two. Number two.
Two.
Hydrogen is 1 and gain 1. That's 2. Beryllium is 4. It lost 2. Lithium is 3. It lost 1. Boron is
Mm-hmm.
5. Lost 3. Now look at this guy. Each of the hydrogen has 1 proton. Two of them has 2. I mean, each of them has 1 electron. Two of them now have 2 electrons. So all these guys I wrote here, they are all isoelectronic species. They
Mm-hmm.
contain equal number of electrons. Do you understand that?
Yes.
Now let's go. What about the second one? 10 electron species. Neon is number 10, 10 electron. Am I right?
Yes. Seven.
Nitrogen is number 7, you gain 3, making 10.
Mm-hmm.
Oxygen is 8, gain 2, making 10. Fluorine
Mm-hmm.
is 9, gaining 1, making 10.
Mm-hmm.
Sodium is 11, lost 1, 10.
Mm-hmm.
Magnesium 12, lost 2. Up to silicon 14, lost 2. Is that okay? Now look at this other guy now. Oh, good. Look at water.
Mm-hmm.
Water says I have 8 electrons in oxygen, 2 in hydrogen. That's 10. Hydroxide, 8 in oxygen, 1 in hydrogen, and I've gained 1 more, 10. What about H3O plus? How is it 10 electrons? Explain to me.
Hydrogen has 3, and then oxygen has 8,
Making 11.
and then lost 1, making
That's
it
common
10.
sense. So all of these guys, they have 10 electrons, all of them. The next one, they all have 18 electrons. Is that okay? So chemical species, can you read this?
Chemical species containing equal number of electrons are said to be isoelectronic.
Do you get the point now? Settled. I'm done with that again.
So, sorry, for the hydroxide, the negative one, it has 10 electrons?
Yeah, we show you that time now, right? How many electrons
8.
in oxygen? 8. 1 nitrogen, 9. Now gain 1, now become 10.
Oh, okay.
Do you agree?
Yes.
Question is, you must think fast, too. Because you know what? Some
Yes.
of the OBJ, some of them will take you 2 minutes to do the working. Some, like this one, just speak the answer without even thinking. Just speak it. So I give many examples. When I ask I give many examples. So you are used to them. Some when I see that, I don't think. I just speak the answer. I don't think. It's like
Okay.
saying, you ask me, where's my right hand? I just let you know my right hand. I won't think that, which one is my right hand? Is it this one or this one? I won't think like that. I just say the answer. So when you practice them to a level, it time come down in the exam, you not think before you give the answer. You don't think. It doesn't just come naturally. Now it comes naturally. So that you can spend more time with other. And to have an A star, you need to think that way. There's no other way to have a star. Is that okay? Some question will waste your time. So you must not waste time on some simple question. Do you get the point?
Yes, sir.
Good. Now let's go on. Next one. I'm done about that. What number we did now? Is that number 6?
And then number
Have we
7.
done 6?
Yes.
Now 7.
State and explain qualitatively the variations in atomic radius and ionic radius across a period and down a group.
Now I'm going to skip that topic. I'm going to skip this. You know why? Let me skip. Let me tell you why I'm going to do it. I don't believe it should be here. I don't know how they are doing it. Please, 1 minute. Please, 1 minute, please. Tamuda, 1 minute.
Okay.
1 minute. Aisha. Please, 1 minute. I'll be with you now. 1 minute, just 1 minute.
No problem.
3.8. Go. I'm back, Tamada.
Yeah.
So come and see why I will skip this topic. Come and see the topic. Come and see them thing here. They say you should teach it on another topic in the future. Here, we are not to go deep. We are just to teach it on surface. Come and see it here now. Yeah. Hold on. Can you read this for me? Hold on, read. Hold on. Yeah, read this. Read number 1. Can you read it?
Yes. Describe qualitatively and indicate the periodicity and the variations in atomic radius, ionic radius.
Same thing again. Where am I teaching then? And here, I want to explain it better here. I'm skipping it there. I'm not doing it there. When I come here, I'll teach it. Is that okay? It's written in 2 places, so there's no point. Because actually, it's story. And what I'm doing now is not story. It's waste time. So let me keep it for the future. When I get there, I'll handle it. Is that okay? I'm skipping it. So just know that I'm not. So in case you see this in part, in case you see this in part of the question I'll be sending to you, just skip it. You know, I'm not taught to atomic structure. They said, what's the variation? I mean, atomic radius. I'm not taught to, so I'm skipping this now. It's for the future. We take it under periodicity. Now I'm done with the first part. Second part, now let's go. Can you read?
Isotopes.
Yeah,
define the term isotope in terms of numbers of protons and neutrons.
Yeah, can you define what are isotopes?
Isotopes are elements with the same number of protons and different number of neutrons.
Thank you. They are atoms of the same element with the same proton number but different neutron number. Yeah, go on. What do you mean by isotope? Would they have? Okay, now let's go to syllabus. Yeah, can you read next one?
Understand the notation. A for isotopes, where X is the mass of nuclear number and Y is the atomic or proton number.
They are saying there's a way to do this. Let's see. Look at this. They give you something like this way to do it. 14 cis carbon, 13 cis carbon, 12 cis carbon. Why do we say this guy? Why do we say they are all carbon? What makes them carbon?
They have the same number of protons.
What makes them carbon?
What makes them carbon?
Why do you say this guy is carbon? Yeah, why can't you call it nitrogen? What makes an element? Why do you call that element carbon? Because it has 6 protons. Anything that has 6 protons is carbon. Do you get it now? Proton is what identifies. Proton is like your fingerprint. No two different human beings have the same fingerprint. No two different atoms have the same. If you like go and put 1,000 here, if the guy is 6, it's still carbon. I don't care what you call it. If you like put 1 million on top, if that one is carbon, if it's 6, it's carbon. Trust me. So hydrogen is an atom that has 1 proton. Do you get the point now? What's helium? Helium is an atom that contains 2 protons. I don't care how many neutrons it contains. I don't care. So that contains 2 protons is a helium. Lithium is an atom that contains 3 protons. Do you get any atom that contains 3 protons? It's lithium. Call it energy is lithium. Do you get the point now? These guys are called carbon because they have 6 protons. So proton number identifies an element, makes the element unique. Is that okay? So you have to calculate this, and we have done this before, right? You can fill it up yourself. Am I right? Yes. You have to do 2 minus plus. You are doing from the proton 666. That's proton. Neutron 876. Now electron now. It has gained to 8. 6. It has lost 1. 5. Again now. So you need to work out this. That's simple. Let's go back to our syllabus. Number 2. Number 3. Go on.
State that and explain why isotopes of the same element have the same chemical properties. This one, same number. Sorry.
Go on. Tell me. I'm listening.
You mentioned that electrons are the ones that take part in the chemical reactions. So electrons
so
are the same number.
If they said 2 marks, the answer would be they have the same number of electrons, they also have the same number of electrons in the outer shell.
Okay.
If they said, but they just say 1 mark, just say they have same number of electrons in the outer shell. Not all electrons are involved in chemical bonding. Is that correct, Lamunda?
Okay, yes,
only sir. The outer shell electrons are involved in chemical bonding. So if they want 1 mark, say, why do isotopes have same chemical property? The answer will be that they have same number of electrons in the outer shell. It's not all electrons that are involved in chemical, only the electrons in the outer shell are involved. Because they have the same number of electrons in the outer shell, they either gain the same number of electrons, or they lose the same number of electrons, or they share the same number of electrons. Is that okay?
Yes.
Good. So I'm sure that makes sense. Next one. Next point.
State that and explain why isotopes of the same element have different physical properties limited to mass and density.
Because they have, now look at this. What's it? They call this guy, why do they call it heavy water? Let me show you something. Yeah, this guy. The normal water you know is this H2O, and it is 1 hydrogen, 16 8 oxygen. 2. This is the normal water you know. That means the MR of this guy, the molecular mass will be what? With there's 2 here. 1 times 2 for hydrogen plus 16 times no, there's no 2 there, sorry. Plus 16 for oxygen. That'll give you what? 18. Now, it now told you that MR of a special type of water was found to be 20. So what could that be? It could be 2 1 hydrogen 2 16 8 oxygen. It could be 1 1 hydrogen 2 18 8 oxygen. Let me explain to you. Please pay attention. The first one, the hydrogen involved there has a mass of 2. Do you agree? It's not 1. There are 3 isotopes of hydrogen. We have 1 1 hydrogen, 2 1 hydrogen, 3 1 hydrogen. They are all isotopes. Are you there? There are 3 types of oxygen: 16 8 oxygen, 17 8 oxygen, 18 8 oxygen. Do you get the point now? So when you say water has a molar mass of 20, that means one of the hydrogen or oxygen must have been what? It must have been replaced. So here, what does it mean? Hydrogen is 2, right? It will be 2 times 2 plus what? Plus 16 for oxygen. That will be what? 20. Do you agree? Whereby here, it will be hydrogen is still 1. Hydrogen is 1 times 2, but this time plus 18 oxygen. You still be 20. Do you get the point?
Yes.
What if I now give you this? 2 1 hydrogen 2 18 8 oxygen. What will be the molar mass of this guy? Hydrogen is now 2 here. It's 2 times 1 hydrogen plus 18. 2 times 2 hydrogen. What does it give you? 22. Good. So we call them heavy water that are heavier than normal. Why are they heavier than other? Because of the different isotopes involved. So water isotopes make different water to have different masses. Therefore, isotopes will have different physical properties. Like what? Like mass and therefore density. They have the same size. What I mean is this. Look at this guy. This guy is this atom of oxygen. Atom of oxygen. The mass of this is 16 grams. This is 17 grams per mole. This is 18 grams per mole. Of course, they have different masses. Am I right?
Yes.
Because the sizes are the same. Who will now have the greater density? Of course, the last one. So this guy should have what? Number one, different masses. Am I right? Number two, what again? What else again? Different densities. So isotopes have different physical properties like what? Like masses and density. But they have similar chemical properties. Similar. Why? They all have the same number of electrons in the outer shell. Therefore, chemically, they are the same thing. Is that okay? The meaning is this. Do you get it? The meaning is this. Carbon 12 plus oxygen, we give you carbon dioxide. Carbon 13 plus oxygen, we give you what? Carbon dioxide again. Carbon 14 plus oxygen, we still give you carbon dioxide. But this one we have molar mass of what? 12 plus 16 times 2. That'll be 44. Then I'll give you 13 plus 16 times 2. That'll be 45. I'll give you 14 plus 16 times 2. That'll be what? 46. You get it for now. They all have the same, they behave the same way chemically, but they have different masses. Is that okay? I'm done with that. Next one, last one, please. Set and explain. Oh, we are done with that. We are done with that. Am I right? We have done number 4. Am I right?
Yes.
So let the latter part of the topic now. Hello, Tamuda.
Yes, sir.
You are doing a special program. You only have 4 hours with me in a week. I won't be explaining something so detailed to you. I'll send the note. You have to read up many things yourself. I'll send the note and the material.
No
So some
problem.
things I will not give you enough example. I'll just give one example because I need to finish my syllabus. We are writing the AS exam mid next year. So I need to finish syllabus later by March or April, max. Start your own MA, you can do your revision, do your exam. You can have your Insta. Good. So let's go. This one. We have this latter part of this topic. There are 3 out of the topic. We have done the first part. This is part of topic 1. Then let's go. Can you read?
Understand the terms shells, subshells, and orbitals.
Go on.
Principal quantum number, ground state, limited to electronic configuration.
Now, IGCSE did not do justice to this topic. This topic, it was not addressed at all in IGCSE. It wasn't addressed at all. Now, I hope, I've heard about WAEC before WAEC. Hello?
Yes, sir.
Have you heard about WAEC before? WAEC. Yes. West African Examination Council.
I've never heard of it.
Okay, it's all right. It's okay. It's also level done in most West African countries. He addressed all these topics. So some of them, these are not in IGCSE at all. So you have to pay attention here now. Let's start. Right. Element in the same period. What is common to them? Do you hear my question?
No, so what did you say?
Elements in the same period. What is common to them?
Element in the same period, the charges, no?
In the same period. So can you pay attention? Whereby element in the same shell, in the same group, what's common to them?
In the same group, the density?
No, you know it too. No, Tamada, I won't take that from you. You know it. Relax. Can you relax? Lithium, sodium, potassium, they are all in group 1 elements. What is common to all of them?
Same charge.
What makes them have the same charge?
They lose the same number of
electrons. Same number of electrons in the outer shell. That's the answer.
Okay.
Elements in the same group have same number of electrons in the outer shell.
Mm-hmm.
Whereby element in the same period.
Same number of shells.
Now you are talking. I know you know it. I know you know the same number of what? Of electrons in the outer shell. Now, element is called, I'm going to apply it here. Elements in same group. Elements in same group have same number of electrons, the same number of what? Of electron shells. And let's go. Now let me take some elements for you. Now look at it. Hydrogen is 1, helium is 2. Now just pay attention. Lithium, beryllium, boron, carbon, nitrogen, oxygen. No, it's too fun. I want to spread them as very well so that I can write on them. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, nearly sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Just pay attention. Potassium, calcium. It's too close to the. I want to write something there. It's too close. So this is sodium, potassium. Now let's go. I want to write the atomic number in red now. I write the atomic number in red. Let's go. Hydrogen is 1, helium is 2, lithium is 3, this guy is 11, this guy is 19, 4, 12, 20, 5, 13. That's not clear enough. You need to get this. You understand it. You understand everything in the topic. Don't worry.
Okay.
6, 14, 7, 15, 8, 16, 9, 17, 10, 18. Those are the atomic number. And those are the number of electrons that they have all together in the atom. So now, how are electrons in hydrogen distributed? Hydrogen just 1, meaning 1 shell, 1 electron. 1 shell, 2 electrons. This guy is now 2, 1. 2 shells, 2 electrons in the inner shell, 1 in the outer shell. This will now be what? 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. So period 2 element, they all have 2 electron shell. Do you agree? They all have 2 shell in their two shell in their what? In their atom. Now let me do this. So let's go. Well, oh, sorry. Now what about sodium? Number 11, 281, 282,
282,
283,
283,
284, 285, 286, 287, 288. And potassium now, 2881, 2882. Can you see now? So elements in the same period have same number of electron shell. Settled. What is changing across the period from left to right? Something is changing. What is changing? Number of shell is constant, but something is changing. What is changing in a period going from left to right? What can you say is changing?
What's exchanging? The number of
something is on. There is a change that's occurring as we're going from one element to the other, across a period from left to right. Something is changing. What is that thing that you can observe? What change can you observe?
the number
Number
of
of electrons in the outer shell. Do you agree?
yes, sir.
Is increasing by 1 from left to right. From lithium 1, beryllium 2, boron 3, carbon 4, up to that. You now go back to sodium again. 1, 2, 3, up to argon, which is 8. So across a period, number of electrons in the outer shell is increasing. The number of electron shell is constant. Do you get the point now?
Yes.
What about down the group? What is constant down the group? Number of outer shell electron is constant. Is that correct?
Yes.
What is now changing down the group? What's changing?
The number of shells.
Number of shell is changing. I like that. Number of shell is changing. And so I think you have the foundation for this now. You can talk about it now. You can talk about it now. Good. So with this understanding, now let's now go. So we know that element within the same group, same number of outer shell electron, but element within the same period, same number of electron shell. Is that okay? Good. Now let's go. Look at this now. I'll talk about shell or energy level. I'll talk about subshell or sublevel. I'll talk about orbital. I'll talk about electron. Pay attention. I'll say it now. Electrons, I'm starting from the down one. Electrons are located inside the orbital. One or more orbital come together to form a subshell. One or more subshell come together to form a shell. Do you get the explanation? I'll say that again. Electrons are found in the orbital. One or more orbital make up a subshell or sublevel. One or more subshell make up a shell. So of these 4 guys written there, which one is the most complex?
The orbital.
Relax, I'll say it again. Electrons are found in the orbitals. One or more orbitals make up a shell. One or more electrons are found in the orbital, right? Then one or more orbitals make up a subshell. One or more subshell make up a shell.
Okay.
Which one is the most complex? It's like saying cell. 2 or more cells make up a tissue. Am I right? Okay. 2 or more tissue make up an organ. An organ is what? A system. Do you get the point now? I'm asking now here. Which one is the most complex here?
It's the shell.
The shell. Do you get the point now? The shell. I like that. Now let me say it another way for you. Now consider a building made up of 4 flats. 4 flats. A building, a block of 4 flats. The whole block of 4 flats is a shell. A flat within a block is a subshell. A room within a flat is the orbital. A pen in a room is the electron. The whole set of 4 black. The whole set of 4 block. The whole 4 black. 4 flats. All the 4 together is a shell. If you focus on one of the flats alone, just one of the flats, that's a subshell. If you now focus on one of the rooms in the flats, one of the rooms, that's an orbital. If you now see a pen on a table in one of the rooms, the pen is an electron. So listen, the pen is found in the room. The room is part of a flat. The flat is part of the block.
Okay.
Do you get the point now? So shell is the most complex. Is that okay? So one or more shell consists of one or more subshell. A subshell consists of one or more orbitals. An orbital contains 1 or 2 electrons. Is that okay? So without understand, let's go. So the orbital that we have orbitals. We have 4 types of them. We have s orbital. It is spherical in shape. We have p orbital. It is dumbbell shape. We have d orbital. Not your syllabus now, is in A2. I'll just mention it. Don't worry, say about this orbital now.
Okay.
D orbital. F orbital is complex. Don't worry, nobody asks you about the shape, it's complex. Is that okay? So there are 3 types of orbital that electron can be found. Some orbitals are called s orbital. Based on their shape, they are spherical in shape. This guy is dumbbell. This guy is like a clover leaf shape, clover leaf. Is that okay? And the other one, is that okay? Now let's go. This is how you understand it. 1s, 2s, 3s. Don't ask me questions. 4s until I'm done. 5s, 6s, 7s. Let me minimize it. I can write together. I'll just write it. Now I'm going for P2 now. P, 2p, 3p, 4p, 5p, 6p, 7p. Now I'm going for 3D now. 3D, 4D, 5D, 6D, 7D, and finally 4F, 5F, 6F, 7F. The meaning is this. Shell number one. How many types of orbital can you find in shell number one?
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdXL and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the EdXL. So we have for the Cambridge E levels and EdXL E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Ajiro Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the system. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, when this is in 2026, when this is 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
One.
What type of orbital is that? This is
S
shell
orbital.
number one. Thank you. What about shell number two? S and
2,
P. What about shell number three?
3,
SPD. What about shell number four downward?
4,
SPDF.
5, 6,
There are four types of orbital for 11. I know there's a G orbital. Don't worry, nobody else knows one. S orbital. Shell number one contains one type of orbital, S only. Shell number two contains S and P orbitals. Shell number three contains SP and D orbital. 4 or greater than 4 contain SPDF orbital. Settled?
Mm-hmm.
It's just 1 minute. Let me know that. Okay, just 3 o'clock. It's come 1 hour. Don't worry. I think we are moving at the good pace. No, we are making progress. Now let's go. Now, actually, please prepare your mind. Though. Please plan for this. Oh. This
Okay.
is a shell. This is a shell. This is also a shell.
Mm-hmm.
Shell 4. How many subshell are in shell 4? Shell 4
4.
consists of 4s, 4p, 4d, and 4f subshell.
Okay.
Shell 4, prepare the shell 4 consists of what? 4
S
subshells, which are what? S subshell,
T
P subshell, D
D
subshell, F
and F.
subshell. Now, where do we now have the place of orbital? Please pay attention now.
Okay.
Any S subshell, I don't care where it is found.
Mm.
S subshell contain only one orbital. This S subshell, S subshell. P subshell contain 3 orbitals. Look at the P subshell.
Okay.
This subshell contain 5 orbitals. Look at this subshell. And F subshell contains 7 orbitals. This F subshell. I'm going to ask you until you understand. I will say it until you get in your head. Don't forget, look at shell number 4. How many subshell are in shell number 4? 4. Now, can you name them?
We have
4
the S
subshell,
and
4
P,
subshell,
D, and F.
4 subshell. Now, what is now the place of how many orbitals are in shell number 4? S subshell contain only 1 orbital. Look at that put here.
1, yes.
What about P subshell? How many orbitals are there? 3
We have
orbitals.
3,
What about D subshell?
5,
5. What about F subshell? 7.
8.
7.
Oh,
7.
7.
I'm going to ask you, shell number 4. How many orbitals are there in shell number 4? It will be 1 plus 3 plus 5 plus 7. That'll be 16.
Okay.
You will not grab it now. But I say it again, you grab it. Don't worry. Just relax.
All right.
Look at shell number 3. How many subshell are in shell number 3?
Shell number 3.
Subshell. 3
Uh,
subshell. 3S, 3P, and 3D subshells. Are you there?
yes.
How many orbital can you find in S subshell? I don't care where the S subshell you find. It's only 1 orbital. So 3S contain 1 orbital. 3P contains 3 orbitals. 3D contains 5 orbitals. So how many orbitals are in shell number 3?
3.
Shell number 3. How many subshell? 3. And how many orbitals?
Orbitals, 3.
You 3S contain 1 orbital. 3P contain 3 orbitals. 3D contain 5 orbitals. Okay, don't worry. Don't worry. You're not the one that will play this way. Don't worry. Don't worry. Yeah, look at it. Can we start again? Can you relax now and go for it? I'll summarize in this table. I first if I explain to you that you understand now. Start again. Can you read? Quantum number.
Quantum numbers describe the energy of an electron within a shell, a subshell, and an orbital.
Now, when we say quantum numbers, there are many of them. But they said the only one they said you should know is what? Principal quantum number, which is the shell number. You know that. Principal quantum number is what? It refers to the shell number. Principal quantum number. Principal quantum number means what? Shell number. Bear that in mind. There are 4 types of quantum number. This is the only way your syllabus is fine. Should I just stick to this? Principal quantum number means what? Shell number. Is that okay? Let's go. Shell number 1. How many subshells does he have?
1.
Look at the table. 1. How do you get that? Come back here. This is shell number 1. Oh God. Wait, Sada. Thank God. This is shell number 1. I'll cross for you now. Shell number 1, 1 subshell. Shell number 2, 2 subshells. Shell number 3, 3 subshells. Shell number 4, 4 subshells. Is that okay? Shell number 5, 4 subshells. Shell number 6, 6 subshells. Shell number 7, 7 subshells. I mean 4 subshells. From shell number 4 downward, they all have 4 subshells. Is that okay? So now come back here. So I want to correlate this table with this table I'm doing. Is that okay? Shell
Okay.
number 1 has only one subshell, which is S subshell. S always contain one orbital.
Mm-hmm.
And this is one orbital we are talking about. You only contain one orbital. This is it.
Okay.
And an orbital cannot hold more than 2 electrons.
Mm-hmm.
Any orbital, whether it's S orbital or P orbital or D orbital or F orbital. Now look at it. Look at this. I'll change S subshell, S orbital. S subshell is one orbital, contain one orbital. P subshell, there are 3 orbitals there.
Mm-hmm.
Each orbital can only hold 2 electrons. Is that more than that? Is that okay?
Mm-hmm.
So I don't care. Is that okay? Now,
Yes.
this subshell has 5 orbitals. F subshell has 7 orbitals. 2, 3, 4, 5, 6, 7. So question 1. How many electrons can a p orbital hold?
Sorry.
How many electrons can be contained in a p orbital?
A p 2 for or in a p orbital.
2 electrons. S orbital, 2 electrons. Pay attention. Just be following me. D
Okay.
orbital, 2 electrons. F orbital is 2 electrons. Any orbital can contain 2 electrons. But now when I now say S subshell, or let me start with P, since I've said, but let me swap these two. S orbital, P orbital. When I now say S subshell, S subshell contain only one orbital. So electron that I can hold is 2 electrons. P subshell, how many orbitals are in P subshell?
3.
How many orbitals are in P subshell? Look at it here. How many orbitals are there?
There are 3.
So how many electrons can it hold? 6 electrons maximally.
6.
Are you following
Okay.
me? Now
Yes.
this subshell,
5
how many
orbitals.
orbitals can it hold? 5. So how many electrons can it hold together? 10 electrons.
10.
So don't mix up the word subshell and orbital. You'll be wrong. You'll be far from the answer. You must be conscious to use the right word. Every orbital, whether it is S orbital, P orbital, D orbital, F, any orbital, is only 2 electrons can hold.
Okay.
We now graduate from orbital to subshell. Now, that's okay. What about subshell? Oh, some subshell contain one orbital. Some contain more than one orbital. For example, S subshell only one orbital. But P subshell contain 3 orbitals. D subshell contain 5 orbitals. F subshell contains 7 orbitals. So question 1, how many electrons can S subshell hold?
That's
Yeah, thank you. S subshell can hold 2 electrons. What about P subshell? 6 electrons.
6 electrons.
What about D subshell? 10 electrons.
10.
I think I have 14 electrons.
14.
But there are 7 orbitals there. Is that okay?
Yes.
Actually, G subshell can hold 18 electrons. How many orbitals are there? It's not
9.
syllabus, don't worry. Thank you, 9. Because every orbital can only hold 2 electrons. How many
Yes.
2 electrons? Is that okay? So don't mix up the word subshell and orbital. They are it's an unforgivable offense in Cambridge.
Okay.
You must take time to use it and use the right word. You can't say, we want to say eyes, now say mouth. How can you call eyes mouth? That's different now. Is as bad as that. So you cannot call, so just know that any orbital, irrespective of where it comes from, can only hold 2 electrons. That's number 1 point. Now, subshell some of them contain 1 orbital, some contain more than 1 orbital. S subshell contains only 1 orbital. So S orbital can hold 2 electrons. S subshell can also hold 2 electrons. P subshell contains 3 orbitals, each of which can hold 2 electrons. Therefore, P subshell can hold 6 electrons altogether. D subshell 5 orbital, therefore 10 electrons altogether. F subshell 14 orbital, 7 orbital, therefore 14 electrons together. Now, we are not saying that F must contain 14. We are saying they cannot hold more than 14. It may contain 1. You can see F1, F2, F3 can be contain 5, can contain 10. They cannot contain more than 14. We are saying that D can contain 1, 2, 3, 4. They cannot contain more than 10. Is that the point now? Now go back to this table now, whether the table may not make sense to you. Look at this table now. Now look at it. Shell number 1 has one subshell, which is S subshell. S subshell contain only one orbital. Therefore, shell number 1 can only hold a maximum number of 2 electrons. Now, shell number 2 here contain 2 subshells, which are what? S subshell and P subshell. Come and see them here. Shell number 2, this is shell number 2 now, right? Contain what? S and P subshell, right? S subshell contain only one orbital. P contains 3 orbitals. Therefore, shell number 2 has a maximum number of 4 orbitals. Do you agree? Shell number 2 has a maximum number of 4 orbitals, and each of them can contain 2 electrons. Therefore, altogether 8 electrons. Is that okay?
Yes.
Does that make sense?
Yes, sir.
Shell number 3, how many subshells are there?
There are 3 subshells.
What are their names? S, P, and D.
D.
S is always 1 orbital. P is always 3 orbitals. P is always 5, making how many orbitals altogether? 9 orbitals. And each orbital can contain 2 electrons. So how many electrons altogether? 18 electrons.
18.
And finally, greater than, oh, I didn't write, I should have written like this. Greater or equal to 4. Do you get the point now? Fine, let me save it. Okay, I've saved it. So greater or equal to 4, they contain 4 subshells. SPDF, S contains 1 orbital, P contains 3, D contains 5, F. So altogether, what is the maximum number of orbitals that can be found in the 4th shell?
9 plus 7.
16.
That's 16.
Now, what is now the maximum number of electrons that can be found in the 4th shell?
That's 32.
That is because you said 16 orbitals. Each of which can only hold 2 electrons, meaning 32 electrons. Does that make any sense here?
Yes.
1 minute, please. Okay, that's good. I'm looking at my battery level. It's 344. I think it can't do here. That's fine. So good. I think this is fine. Now, there are now rules for filling orbitals with electron. Or no, number 1, let me talk about rules for filling subshell. This guy I wrote here. Can you say these guys are orbitals or subshells? These guys. Are they orbitals or subshells? The way I wrote them.
These are
Each of them, 1s, 2s, 3s, 3f. Are they subshell or orbitals?
These are orbitals.
No. If it's orbital, 4p should have been 3. It should have been drawn in 3 places. These are subshells.
Subshells.
Thank you. Do you have any subshell? Please know this. Like I told you, I'm just saying today. I don't want to make you say these are what subshells.
Subshells.
Now look at it. Now this is how we drew them. 1. Look at the way I drew my arrow. It was found that these subshells, they have energy based on how far they are from the nucleus. The closer they are to the nucleus, the lesser the energy. Is that okay? The subshells, the closer to the nucleus, the lower the energy. Now, let me ask you this. If electron is coming and see 2 subshells, one has higher energy, the other has lower energy, where will electron naturally go to? Everything in life want to be stable. Let me give you an instance. Not only in chemistry, in science, in life, everything want to be stable. Everything want to be stable. Don't forget that. Everything want to be stable. Now I'm asking you now, electron is coming, saw an orbital with higher energy, you saw another with lower energy, lower. Where will it go to, electron? Will it go to higher energy or lower energy? Don't forget, everything in life is tending towards being stable. Yeah, where will it go to? Lower energy or higher energy?
Lower.
Thank you, because low energy is stable than high energy. When you
Mm-hmm.
are sitting on the ground, you are more stable than when you are standing up. Do you agree?
Yes.
He that is down fears no fall. You are sitting on the ground. You know you can't fall again. If there is breeze is blowing, you know it can't blow you off. You are sitting on the ground already. But that's why they said that when there is breeze, when there is all this, what they call this thing that happen in all this American country, aka Canada, what is one way when it's blowing so much? He said, try to go and sit down in a place. Just find a corner and sit down. But not under the tree, because tree can fall and fall on you. Just sit down. Don't try to be, don't run. We run, the breeze can blow you away. Do you get it? My point is this: electrons occupy orbitals of lower energy before those of higher energy. Know that. Electrons occupy subshells of lower energy. Electrons occupy subshells of what? Of lower energy before occupying those with higher energy. That's rule one. I think it's in the note. Let me see if it's in the note. Oh, good. Yeah, can you read it? 3 rules. Can you read them? Number 1, 2, 3.
Number 1, an orbital can only hold 2 electrons which must have opposite spins. For example, electrons occupy orbitals
Tell
of
me, this electron is the electron. They have one is rotating clockwise, the other is rotating anti-clockwise. Is that okay?
okay.
Cannot hold more than 2 electrons. Number 2.
Electrons occupy orbitals of lower energy before those of higher energy.
Second. Number 3.
Degenerate orbitals are filled singly first before pairing of electrons occurs.
What are the energy orbitals?
Degenerate orbitals, different.
Read it, is there.
Degenerate orbitals have same energy but different orientations along the axis.
Example of that. Let's use unit orbital so that you can understand it very well. We'll now get to question now. We have look at it. When you say 3p, p subshell, 3p subshell, it has 3px, 3py, and 3pz orbitals. Look at them. You get the point now. So when you do now, when you do things like, let me do for let me do for oxygen is number 8. Come and start from here. Which one will I take first? S. I'm like one. Look at it. Follow the arrow. Which one will I take first?
Okay, it's first S,
One
S
S, not
P,
just S. One S. No.
one
Start
S,
again. Uh-huh. Be
two
careful. Don't
S,
miss it. Go on. I like that.
two P,
I like that. Go on.
three S,
Go on.
three P, three D, and then
Mm-hmm. After TDP, look at it very well. What's the next?
oh, okay. From three P we go to, is that five S?
4S. 4S. 3P to
P.
4. Look at the arrow. Follow the arrow. Follow the arrow.
From 4S we go to 3P.
3D.
Then
The arrow is going from top down. It's going from right to left. Start again.
okay, 1S,
Go on.
2S,
Uh-huh.
2P,
Go on.
3S,
Go on.
3P,
Go
4S,
on. Uh-huh. Go
3
on.
3D, 4P,
Uh-huh.
5S,
Uh-huh. Go on.
4D, 5P, 6S,
Go on.
4F, 5D, 6P, 7S,
Go on.
5F, 6D, 7P,
Go on.
6F, 7D,
And
then
finally,
7F.
now you got it. Now, this is the order in which the energy goes.
Okay.
The subshell with the smallest energy here is 1s. Therefore, electron must enter 1s before any other subshell. After 1s is filled, now go to 2s. After that, it goes to 2p. then 3s, 3p, it goes to 4s before 3d. Look at it. After 3d, 4p, it goes to 5s before 4d. After 4d, 5p, it goes to 6s before 4f. It's not about where, it's about your energy. What determines your energy is what? How close you are to the nucleus. Those which are very close to the nucleus have lower energy. They receive electron first. Those which are far from the nucleus have higher energy. They receive electron last. Is that okay? So let's do the first 20 elements. Or the first, I'll do the first 30 elements for you. Then with that, I'm sure you can do any element they ask you. I mean, you can do anyone they ask you. Let's start from the beginning. Hydrogen is number 1. If you look at that thing, is 1s1. Helium is number 2. It's still 1s2. I'm done with the period 1. I'm going to lithium now. Lithium is number 3. Is 1s2, 2s1. Look at it. After 1s, what's the next one? 2s. I'm gonna look at it. After 1s, what's the next? 2s. After 2s is 2p. Don't forget it's 2p after 2s. Don't forget to. Okay. So you may have to draw that and you get. Yeah, I don't need that thing again because I've drawn it a million times and I know it in my head. Do you get the point now? So when you practice it, time come down, you just say you won't have to struggle with it again. It just become part of you, like you know your name. You can't forget your name. Now, beryllium is number 4. Is 1s2, 2s2. Boron is number 5 now. Is 1s2, 2s2. It goes to 2p1. Remember, 2p subshell has 3 orbitals. So it can go to from 2p1 to 2p6. Is that okay? 1s subshell, 1 orbital cannot contain more than 2. S cannot contain more than 2. But P can contain up to 6 electrons because there are 3 orbitals there. D can contain up to 10 electrons because there are 5 orbitals there. F can contain up to 14 electrons because there are 7 orbitals there. Is that okay? Let's go on. Boron, carbon, nitrogen, oxygen. Carbon is 1s2, 2s2, 2p2. 1s2, 2s2, 2p3. 1s2, 2s2, 2p4. This topic is one of the most important topics you learn in chemistry because it paves you to many other things. Fluorine, 1s2, 2s2, 2p5. Then neon, number 10, is 1s2, 2s2. Now 2p is fully filled now. I cannot go further. We are done with p. Let's go and see the next after 2p. After 2p, what's the next? Tamunda?
After 2p,
yes.
we go to 3p.
No. Look at the arrow. Look at the arrow. Look. After 2p, follow the arrow.
2p,
you are going
3s.
from right to left. Don't make that mistake. You are going from right to left. Follow the arrow. You are following downward until you get it. You now go to the top again. You are following the arrow downward from right to left. When you finish the last person on the left, now come to the back again and start all over again. Is that okay?
Yes.
Does it make any sense?
It does.
You will know it when you know it. Don't worry, it's simple. And you will like this topic. I'm telling you, when you finish it. Now, sodium is number 11 now. It is what? 1s2, 2s2, 2p6. Now 3s1.
S1.
Magnesium is number 12. Is 1s2, 2s2, 2p6, 3s2. I'm done with s2. Can only contain 2. So I'm done with s. Let me go and see the next one after 3s. After 3s, what's the next?
We go to 3p.
Thank you. I like that. That you know the first 30 elements. They cannot ask any other one. That if you know the first 30, that you can write it on that one. That's what can be said. Aluminum is number 13. It is 1s2, 2s2, 2p6, 3s2, 3p1. So silicon is number 14. 1s2, 2s2, 2p6, 3s2, 3p1. Then phosphorus is number 15. 1s2, 2s2, 2p6, 3s2, 3p2, 3p3. This should be 2. Then sulfur is number 16. 1s2, 2s2, 2p6, 3s2, 3p4. Then now, chlorine is number 17, 1s2, 2s2, 2p6, 3s2, 3p6, 3p5 rather. Then argon is number 18, 1s2, 2s2, 2p6, 3p2, 3p6. So I'm done with pieces now. Let's now go and see the next guy after 3p6. What's the next one?
After 3p, 4s.
After 4s in call.
Sorry?
After 4s. What about after 4s? What happened after 4s?
After 4s, we go to 3d.
So after 4s, 3d. Don't forget that.
Okay.
Let's go. So without some, so I'm done with period 2 elements. Period 4 now. Period 3 is 19 is what? Instead of writing all of this, can I just write this? You know what that means? It means 1s2, 2s2, 2p6, 3s2, 3p6. Instead of writing those, I'm saving time. Do you get?
Oh, okay.
So this one also collaborating at you know this guy. So them collaborating as this. Neon 3s1. Do you get? Collaborating as what? Neon 3s2 to shorten time. Do you get it by now?
Yes.
The only one we can put in brackets is the noble gas. What's the noble gas? Which group do they belong to?
Group 8.
Thank you. So noble gas are the one you can put in bracket. You can't put another one in bracket.
Okay.
You can put it in bracket. Is that okay?
Yes.
So now argon, that'll be 4s1. Calcium is about 20. Argon 4s2. Is that okay? Now scandium now. Scandium is about 21. We're going to 3D now.
Okay.
It's what? Argon 4s2, 3d1. Titanium is about 22. Argon 4s2, 3d2. Indium is about 23. Argon 4s2, 3d3. Chromium is number 24. Argon 4s2, 3d4. Are you following me?
Yes.
Manganese is number 25. D can get to 10. You know, D can go to 10, up to 10. It has 5 orbitals. 4s2, 3d5. Iron is number 26. Argon 4s2, 3d6. Then cobalt is number 27. Argon 4s2, 3d7. Nickel is number 28. That'll be argon 4s2, 3d8. I'm not done, don't worry.
Okay.
There's copper is number 29. That'll be argon 4s2, 3d9. And zinc is number 30.
Okay.
That'll be argon 4s2, 3d10. After 3d is 4p. So if you don't want to go to gallium, gallium is number 31. It's argon 4s2, 3d10, 4p1.
Okay.
Then germanium is number 32. That'll be argon 4s2, 3d10, 4p1, 4p2. Then germanium, arsenic. Arsenic is number 33. That'll be argon 4s2. You know, you're not to memorize this. I hope you know. They give you a copy of it in the exam. They give you a copy, so you just don't have to write it. Is that okay?
All right.
You don't have to write. You don't have to memorize them. Well, now selenium is number 34. That'll be argon 4s2, 3d10, 4p4. Then bromine is number 35. That'll be argon 4s2, 3d10, and finally krypton number 36. I'll stop there. Argon 4s2, 3d10, 4p6. Can you see now? Now let's now go now. Now we understand why electron go to S before D. Let me apply the 3 rules. The rule says the generate orbital must be filled singly first. The meaning is this. If you have a P1 system, 3 types of P orbital. We have PX, PY, PZ. PX, PY, PZ, they all have the same amount of energy. The one lies along x-axis. One lies along y-axis. The other lie along z-axis. Is that okay?
Yes.
They all lie along, they have on different words. On different axes. Is that okay? Now, P1 means 1 orbital, 1 electron. P2 means 1, 1. P3 means 1, 1, 1. Give them singly first before you pair them up. They are triplets from the same mother. You have 3 naira. You give them 1, 1, 1. You can't give 1, 2 and give you not give you that one. Is that okay? You not be fair. So P1 by P4 system now it should be 1, 1, 1. Then you can make the guy 2. What about P5 system? 1, 1, 1, 2, 2. By PC system, 1, 1, 1, 2, 2, 2. Is that okay? So question 1, which of these P arrangements, P1 to P6, which of them is symmetrical? Which of them is symmetrical? Symmetry. Symmetrical means even, equal.
Equal.
Which of them is symmetrical? Between P1 to P6. P what? P6 and P3
are equal.
They are symmetrical. P3, all of them are either 1, 1, 1. What about P6? 2, 2, 2. They are fine. Is that okay?
Yes.
Which of them will be a strong oxidizing agent?
Oxidizing.
No, before then, which of them is fully filled and stable? Which of them is fully filled? Fully filled. Therefore, stable. Which one is that?
It's P6.
And that is for noble gases. Can you see how they are stable now? All noble gases are P6. All of them. Except helium, that first guy. Is that okay?
Yes.
Now, which of them is a strong oxidizing agent? In terms of electron, what do they do? Take an electron, lose electron.
Oxidize, oil rig. Loss. It loses.
Madam, that's not to do it. Oil rig. Not oxidation is loss of electron. Oxidation is loss of electron. What about reduction?
Is gain.
Reduction is gain of electron. But the guy that loses electron is a reducing agent. You don't know that before? Yeah, that's right. I'll say that again. Oxidation is loss of electron. But the element that loses electron is a reducing agent. That's right. Right. Oxidation is loss of electron. But the guy that loses electron has been oxidized. So himself is a reducing agent.
Okay.
Should I say that again? You need to get that right. You need to know that is extremely. I'll be using it because I'll be talking Jesus, and it's also in A level. We do it in A level.
Okay.
Oxidation. Let me go right so I can see better. Oxidation. Loss of electrons. But now that's correct. Let me just go. The elements, right, which loses electrons has been oxidized. The element which loses electron has been oxidized. Full stop. Such an element is a reducing agent. Such an element is a reducing agent. Now that we have seen it. A reducing agent is the one which is a reducing agent undergoes oxidation. Do you get the point now? Undergoes oxidation. And while itself is reduced, while itself is what is reduced. That's how to say it. You need to get that right. The oxidation is a loss of electron. The element which loses electron, has been oxidized. Such an element which has been oxidized, you cannot oxidize an oxidizing agent now. Do you get the point now?
Yes.
If you say I've undergone oxidation, that means I'm a reducing agent myself. If I'm an oxidizing agent, you cannot oxidize me. You can only oxidize me because I'm a reducing agent.
Okay.
I'll look for that way of saying. It's like saying a warrior who fights in a battle cannot be killed. He killed others because himself is a warrior.
Yes, sir.
How do I say it again? I'm just saying that if somebody undergoes oxidation, it is not an oxidizing agent. It undergoes oxidation because it's a reducing agent. It undergoes reduction because it's an oxidizing agent. Oxidation is loss of electron. Point one, the element which loses electron has been oxidized. Such an element is a reducing agent. A reducing agent undergoes oxidation while itself is what?
As a reducing agent.
Hold on. A reducing agent undergoes oxidation while itself is what? I mean, that's not correct. A reagent is undergoes oxidation. That is, or let me just say, why it reduces others. That's the best way. While it reduces others. That's the right way to say it. I got that wrong. Look at now how to say it. Look at it now. But that makes sense to you. Oil rig is talking about electron loss and gain. Not the person that loses electron. Though. Don't get it wrong.
Okay.
The process of losing electron is oxidation. But the guy that loses electron is a reducing agent. Do you get another way of saying? Is that okay?
Yes.
The process of losing electron is oxidation. The process of losing electron is what? Is oxidation. Now, the guy that loses electron is a reducing agent. Is that okay?
Yes.
So the other one also hold. All of these are oxidation. You can now say, oh, reduction is the gain of electron. The element which gains electron has been reduced. Such an element is an oxidizing agent.
Okay.
An oxidizing agent undergoes reduction while it reduces others. Is that okay? While it oxidizes others. An oxidizing agent undergoes reduction. I am on oxidizing it because I can oxidize others, not because of me. No. If you call me an oxidizing agent, that means I can oxidize others.
But I myself reduce.
Thank you. I like that. If you call me an oxidizing agent, you are saying that I can oxidize others while I myself I'll be reducing the process.
Okay.
If you call me a reducing agent, you are saying that I can reduce others while myself I'm oxidizing the process. Is that okay?
Yes.
So now a reducing agent can reduce others. A reducing agent can reduce substances while itself is oxidized in the process. Itself is what? Is oxidized in the process. A reducing agent can reduce other substances while itself is oxidized in the process. These are all the things I need to say. Is that okay? The opposite also is true for the other one. Is that okay? Does that make any sense? If you say somebody undergoes oxidation, that guy is a reducing agent. That's why he can undergo oxidation. Is that okay? Does that make any sense?
Yes.
Good. We go over this until it sinks into your mind. Now let's go back. So I'm coming back here. Which of these guy is a strong oxidation. Just remember, and the way you can only know is also metals are reducing agents. Non-metals are oxidizing agents. Metals normally lose electron. They are reducing agents. And because they lose electron, they are oxidized. That's what oil rig means. Oil rig means oil oxidation is loss of electron. If they lose electron, now look at this. Look at it. I will say it until it gets into. Look at this. Na to give Na plus plus E minus. Mg to give what? Mg2 plus plus 2E minus. Now, these processes, are they oxidation or reduction?
Oxidation.
Thank you. They are both oxidation. So which type of element is sodium and magnesium?
The reducing agent.
Can you see now you get it very well? This guy is a reducing agent. This guy is also what? Reducing agent undergoes oxidation. Do you get the concept?
Yes.
When you lose it, you have undergone oxidation. Now you said you are a reducing agent. Is that okay? Now the corollary is true. Let's see. So the corollary is true. Let's see. Let me see what I can do for you. Let's go Cl2 plus 2E minus to give 2Cl minus. Each of them became -1. Then let's go O2 plus 4 electron to give 2O2 minus. Is that okay? Br2 plus 2E minus to give 2Br minus. This is electron gain. This is electron loss. So it is what? It is oxidation. This is what? Electron gain. And that is reduction. So now these guys, now who are they now? Cl2, Br2, and O2 are what? Oxidizing agents. Is that okay?
Yes, sir.
Let's go back this down to the 6 in your mind. Thank you. Let's go back to what we are doing. Now let's go. Which of these guys will be strong? The one that will want to gain electrons so that it can be stable. Which of them will be the strongest oxidizing agent? The one that want to gain so that it can be stable.
That's P5.
I'm talking P5. Now, do you know that of all non-metal, which of them is most willing to gain electron? Which group is that? That the most willing to gain electron?
To give away P4.
Gain electron. No, listen very well. Of all the non-metals, which group of the elements in the non-metals are the most willing to accept? They are very willing to gain 1 electron so that can be stable. Which group is that?
That want to give away to be stable.
They want to gain 1 electron so that it can be stable.
That's group 7.
Thank you. Now group 7 have P7. These are the halogens. They are the one that have this guy. Can you see how can you see how you're interpreting now? Yes. Group 7, all of them have P5. Let me show you. Look at this. Fluorine is number 9. It is 1s2, 2s2, 2p5. Chlorine is number 17. 1s2, 2s2, 2p6, 3s2, 3p5. Bromine is number 35. It is 1s2, 2s2, 2p6, 3s2, 3p5, 3p6, 4s2, 3d10, 4p5. Can you see that? They all end with what? All of them, they all end with P5, P5. Can you see now? They want to gain 1 and become P7 and can be stable. Do you agree to that? All of them end with P5. So all group 7, they all have P5. Now, how do I know? They have 7. Now, look at it. This is shell number 1, 2 electron. Shell number 2, 7 electron. Shell number 1, 2. Shell number 2, 8. Shell number 3, 7. Shell number 1, 2. Shell number 2, 6. Now, shell number 3 is this and this. Do you agree together?
Yes.
Shell number 1 is 2 electron. Shell number 2, 8 electron. Shell number 3, how many electrons? Tell me.
That's 2 plus 6, 8 plus 18.
Now, shell number 4, how many electrons? 7.
7.
This guy is 2, 7, 7 outer shell electron. 2, 8, 7, 7 outer shell electron. This guy is 2, 8, 18, 7. You see 7 outer electron. So when you write for me electron configuration for an alien, I can tell you the group and the belong it belongs to. I can tell you. I'll come to that later. Is that okay? Just give me, I will tell you the group and below. I'll tell you. I just look at the number of electrons in the outer shell. 4s and 4p, they are in the outer shell. Now, why do you think 4s came before 3d?
You're
Because
saying?
4s are, why do you think 4s appear before 3d? Because 4s is at lower energy. Therefore, electrons occupy 4s before 3d. We have said electrons normally occupy orbitals of lower energy before those of higher energy. 4s is what? Is at lower energy. Electrons occupy 4s before 3d. Do you get the point now? Therefore,
Yes.
4s is not before 3d. Do you get the point now? So my point is this. Come back here. We are talking about this guy. So this guy, we know the one that are symmetrical P3 and P6. The ones that are fully filled and therefore stable P6 is for noble gases. The ones that are strong oxidizing agent. Now, there's what we call it electron pair repulsion. That is, others is different from others. We don't like pairing electrons from the beginning because they repel each other. Don't forget, electrons are similarly charged, they are negatively charged, they repel each other. That is why you have to give them singly first before you pair them up. Do you get the point now? So, question one now. Which of these guy that now look at this guy, all of them 2, 2, 2, they won't be any repulsion because they all repel each other. This guy, two are repelling, one is different. But look at P4, two of them are repelling because others are 1, 1. So P4 is willing to lose one electron so that I can become P3. Do you get the point now?
Yes.
Is we can lose because you know what, others are 1, 1. Is the only one that is odd among them. Guys, others are 1. Why are you 2? But look at P5. Will it prefer to lose 2 and become P3, or will it prefer to gain 1 and become P6? Look at P5. Will it prefer to lose 2 and go back to P3, or will it prefer to gain 1 and go to P6? What will P5 do?
It will gain.
Thank you, and become P6 and say, I'm very far from P3. I can't be going back to P3. Let me just gain 1 and become P6. So P5 prefers to gain and become P6. But P4 prefers to lose 1 sometimes and become P3. You get we're very close to P3. So we talk about electron pair repulsion. Electron pair repulsion is occurs in P4. Electron pair what? So I call it spin pair repulsion. I call it electron pair repulsion. Electron pair repulsion occurs in what? In P4. It occurs where you have others as 1, 1, 1. Only one is 2. Should I say that again? Electron pair repulsion occurs where you have 1, 1, 1, 1, 1, and only one of them is 2. Is that okay? Now look at this system. This system. D1 to D10. Do you agree? Is it not D1 to D10? D.
D1 to
Where
D10.
do we have, where do we have electron pair repulsion? There are 5 orbitals. Don't forget to. There are 5 orbitals here. In which of them, D1 to D10, will have electron pair repulsion? Electron pair repulsion occurs where others are 1, 1, 1, and only one of them is 2. Because electron, the guy will say, let me just lose one and go back to others. Is that okay? Where will electron pair repulsion? Which of them will have electron pair repulsion? Which of them will have electron pair repulsion? D9 will be a strong oxidizing agent. Tell me you understand that. We want to gain 1 and become D10.
Yes.
Right? Which one is symmetrical? D5 and D10 are symmetrical, that is evenly occupied. Do you agree? D10 is fully filled and therefore stable. Fully filled, therefore stable. Which one we have electron pair repulsion? Electron pair repulsion. Which of them?
D10.
D10 is fully filled now. They all have 2, 2, 2, 2, 2. They won't repel each other again.
Which one will have repulsion?
Which one has electron pair repulsion? They come back here. Which one has electron pair repulsion? The P what?
Are we saying that if they are paired all together, if it's a full shell,
they won't repel each other again. If we are all wrong, then nobody is wrong. Do you agree? Let me explain that to you.
okay.
Maybe there's a town somewhere in the world. they all eat with their left hand, and they all clean their bum with their right hand. That's how they do in their town. If that's all of them, if that's all they believe, then none of them is wrong. They are all right because nobody will correct another person. Do you get the point now?
Yes.
If we are all wrong, then we are all right. Do you agree? None of us will know that we are wrong.
Okay.
If we are all wrong, I tell you we are all right. You know why? Nobody will know that we are wrong. Do you understand what I'm saying now? Nobody will know that we are wrong. I'm saying that if what now? I think what was I explaining? If all of them have one, if they all have two, there won't be any repulsion again. They will be stable.
Oh,
If they all have two, there won't be any repulsion again. They all be. It's just, guy, it's like all of us. We have two. Let's just endure. Let's not fight each other. We are all two. Let's just endure. And when you have, listen very well. When you have 10 rooms in a room, 10 rooms. Are you listening to me? Or 5 rooms in a room. 6 students are around. 6 students, and I'll give each of you one. The 6th, and I'll say, oh, like, and I'll go and put you in room 1. The guy in room 1 will not be happy with him. Say, why is it that they brought him here? Why can't they take the other place? Why is he here? And now he'll be inconveniencing me now. He'll be inconveniencing me. So they grumbling. Because he's the one that you said, oh, that's a one. Why are you making my own room too? What can't I want my privacy? Do you get the point now?
Yes, I do.
But in a case where you make all of them two, say, guys, welcome to the camp. All of you will be two in a room. They know they have no option. They won't fight each other again. Do you agree? Do that. All of us are two. Let's just endure. Am I right? How long will you stay? So if they are all two, there won't be any repulsion again. But if one of them is 2, others are 1. Those 2 will be repelling themselves because they won't be happy. Say, why must you make me 2 when I can enjoy my privacy? So I'm coming back here now. Question. Which of the D electron, D1 to D10, which of them will have spin pair repulsion? That they each of them will be repelling. D what?
9.
D9 want to gain 1 and become D10. It can be. D9 will be a strong oxidizing agent. It wants to gain 1 and become 10. Spin pair repulsion only occurs when others are 1. Only one of them is 2.
So that's D4 1.
When others are 1, only one of them is 2. Which D system is that?
1 2 3 4 5 6.
Do what?
6.
Why does it take you so long? You should I don't want to tell you, so you got it now. In this is everybody is 1. Only one of them is 2. So they just say, why must you bring him here? Not comfortable with your. He's complaining already that why must I be the only one having 2? What does happen one now? I don't want my privacy.
So you're on mute.
So you have to unmute. So it's just you see the button at the top for the mic. When you go to Teams, the other one. Yeah. Yes, that's it. The mic.
How far?
Yeah, I can hear you now. Yeah, I can hear you now.
I'm sorry.
It's fine.
I'm sorry. So let me continue my work. Am I still sharing my screen?
Yes, sir.
Yeah.
Thank you. Now let's go back to our work. We need to finish this one. Right. Now, please pay attention.
Okay.
If I give you oxygen is what? 1s2, 2s2, 2p4. They will now ask me how many unpaired electrons are in oxygen. This guy, let me write it down. Please pay attention. It's actually 1s2, 2s2, 2px, 2py, 2pz. It's actually 2px, 2py, 2pz. Now, how do you now share 4 electrons among them? Can you tell me? Don't forget the rule. We give them 1 before we start paying up. We just go on.
1 at px, 1 py.
Should be 2 1 1.
Yes.
By the time you give 1 you now come back again and give 2. Do you agree?
Yes.
So, question: how many electron pairs are in oxygen atom? How many electron pairs in O atom?
Three.
How many electron pairs in O atom? How many? Three
Three.
electron pairs. Thank you. 3 electron pairs. Is that okay? How many unpaired electron?
The two unpaired electrons.
I like that. That's very smart of you. That's okay. Now let's now go. How do we represent this guy? Look at it. You can say this is 1s2, 2s a bit higher, 2s2, then 2p has 3 orbitals. And it will be 1, 1, 1, then of course 2. Do you agree? We call this electron in box diagram. 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 That will call that. That is electron represented inside the box. Is that okay?
Yes.
Yes, it's electron in box diagram. I've gone down. Okay, good. Now they all mean the same thing. 1s2, 2s2. This, they are the same. Am I right? These, they are the same. Now let me turn to in terms of electrons in shell. Look at it. Pay attention, please.
Okay.
1s2 shell 1. I'm going to shell 2 now. 2s2. 2p. How many 2? What about 2? How many 2p is there? 2px2. Pay attention. 2px2. 2py1. 2pz1. That's how oxygen should be represented. You can't just say 2, 2, 2. No, that's not true. I'll label them for you. Let me label them for you. This is 1s2. What about this? 2s2. 2px2. 2py1. 2pz1. Do you get the point now?
Yes.
So oxygen has 2 unpaired electrons in the outer shell. You must understand that. If you now want to form covalent bond, to form a covalent bond, I need an unpaired electron. So from this diagram now, if oxygen is to form covalent bond, how many covalent bond can it form?
Sorry?
To form covalent bond, I need an unpaired electron. To form a covalent bond, I need an unpaired electron. Therefore,
Yes.
this guy, how many covalent bond can he form?
2.
Thank you. So that's why oxygen form 2 bonds.
Yes.
This topic is so important that it lays foundation for every other topic you want to think about. It's like this atomic structure. Is that okay? Yes. To form a covalent bond, comma, an unpaired electron is what is required. Is required. Therefore, Mr. Oxygen can form 3. So oxygen cannot form water. Look at oxygen. 1 bond with hydrogen, 1 bond with hydrogen. Now, how many electrons does he have in the outer shell before oxygen?
8.
No, in the outer shell. How many does he have? Check it out. Look at it in your front.
That's 6.
How many has he used to form bond with hydrogen?
It needs 2.
How many has it used? How many has it used to form bond with hydrogen? Use one with this. Use one with this hydrogen. One with this. How many will not be left for him? How many will not be left for him?
Sorry?
He has 6 electrons in the outer shell.
Yes.
Uses 2 to form 2 covalent bond with hydrogen. After forming covalent bond, how many electrons will now be left in the outer shell? It has 6 electrons in the outer shell. Out of the 6, the guy uses 2 to form 2 covalent bond with 2 hydrogen atoms. After forming those covalent bond, how many electrons will now be left in the outer shell?
There'll be now 8 if they bond.
Altogether, how many will be left that were not used to form bond, that were not used to form bond? How many will be left that were not used to form
4.
bond? Thank you, 4. So this guy has 2 electrons. 1, 2.
1,
This is
2.
water molecule.
Okay.
Which what is this? This one is 2s2. What about this one? 2px2. Which one we use to form bond there? Which one we use to form bond there? 2pz1. What about which one we use to form bond there?
2py1.
One. So Mr. Oxygen use 2py1 to form bond with hydrogen. It also used 2pz1 to form bond with hydrogen. He now left 2px2 and 2s2 as lone pairs or non-bonding pairs. This one is the IGCSE. They didn't just explain like this.
Okay.
Tell you that how many lone pairs are present in oxygen atom in water molecule? The answer is 2 lone pairs.
Yeah.
Lone pairs are the electrons in your outer shell which are not used to form covalent bond. Please, can I will round up in the next maybe 2 minutes or 3 minutes. Let me quickly save this. Sometimes I can disappear. I won't be able to save it again. Give me a minute. Just let me save it on my desktop. It's just 1 minute. If I don't save it, there'll be trouble for me. I won't be able to recall it again. No, I think I have it on my desktop. Where's my desktop? When I save it, this. I've created a folder for this. Atomic structure. I will send it with the note I have. Do you get it? So I'm sending 2 notes. The note I've formed before and the note I'm just writing now. Do you get? By the time you read the 2 of them, you'll be able to have a good understanding. Atomic structure. Atomic structure. Good, that's okay. Saved, thank God. And the note I formed before, the changes I made to them, I also saved them. Do you get it? No?
Okay.
Sometimes because I made some changes to them, right? I also saved them. So I'm going to have 2 notes at the end of the day. This one is class note normally. The former one is the real note that I formed before the class. Do you get it now? So you have to read the 2 of them together so that you can have a better understanding. Is that okay? So now let's look at nitrogen. Why do nitrogen form? Look at ammonia molecule. Look at ammonia molecule. Why does nitrogen form 3 bonds? It's very simple to explain. Nitrogen is number 7 and it is 1s2, 2s2, 2p3. What does that mean? 1s2, 2s2, 2px1, 2py1, 2pz1. So it has 3 unpaired electrons. Do you agree to that? 3 unpaired electrons. So you can form a covalent bond. Do you agree? Which is 1s2, 2s2.
1, 1.
Thank you. 1, 1, 1. Thank you. Do you get the pen now? That means it's what it is. 1s2, 2s2, 2px1, 2py1, 2pz1. Do you agree to that?
Yes.
Can form bond with? Can it form ammonia? Yes, we can form ammonia. 2s2, 2px1, 2py1, 2pz1. Hydrogen now say this is nitrogen. I'm showing the outer electron only. Hydrogen now say, can I come and form bond with hydrogen? Now brought 1. This hydrogen. Hydrogen also brought 1. This hydrogen. Hydrogen also brought 1. This hydrogen. So now look at it. Ammonia has 3 bonding pairs. Do you agree?
Yes.
Ammonia has 6 electrons involved in bonding and 1 non-bonding pair. So ammonia, 3 bonding pairs.
And 1 lone pair.
3 bonding pairs or 6 bonding electrons. 6, because each of the pair means 2 electrons, right? And then 1 non-bonding pair. Do you understand that? So that's how we form that. So they can ask to now write this. So again, they cannot ask to write for, like I said, O plus, O2 minus. O is 1s2, 2s2, 2p4. What about O plus? It has lost 1. 2p3. Do you agree?
Yes.
What about O2 minus?
1s2, 2s2,
2p6. Check it, has gained 2, right?
Mm-hmm.
Am I communicating here? So we can actually this P4 that's gained 2, so it becomes P6. Do you agree?
And that one is 2p3.
Lost 1.
5.
Lost. Let me write
that's a positive. Okay.
Yeah, lost 1 electron. Whereby here gained 2 electrons. So you get it. You can write all these manipulations. Do you get it now?
Yes.
So you have to know how many electrons are there in the outer shell and that. Finally, before I go, let me explain this to you before I go, because I've written it for you already. I don't want to read it before I explain it to you. I want to make some changes here, but they're not correct. And I wrote it that way deliberately. Now look at it. When it comes to, look at chromium. Chromium says I am 4s2 and 3d4. But d4 says, why can't I be d5? There are 5 orbitals, I hope you know. This system, there are 5 orbitals there. All of them have 1, 1, 1, except one of them. A d4 system means what? It means this. 1, 2, 3. It means 1, 2, 3, 4. One is empty. You can now say 4s. I'm doing one different from others. Can you just give me one electron? So actually, chromium in real life, chromium is not, this is not correct for chromium. It's supposed to be the best, not correct. Chromium is actually argon. Tell me, 4s1,
3d5.
So I want to be symmetrical. I want to be stable. You guys say d5 is okay. Just give me one electron and let me make me stable. It was too troublesome. Again, now say, don't kill me. Just take one and don't kill me. Then you go for copper. Copper says, no, I'm not taking this from you. So what do copper become? Tell me.
4s1,
4s1,
3d10.
3d10. Because all of them have 2, 2, 2. Only one of them has 1. It was not fighting with others. Give me one. It was fighting with others. Now, say, what is causing trouble there? Say, I just need one electron. I must get one like my friend. He's not okay. Let me just give you one to stop trouble. Let's now give them one. So copper is 4s1, 3d10. Why? A 3d10 system is fully filled. It is symmetrical and stable. The guy, you will just cause him or just give him one. Do you get the point now? So those are the exception there. And this guy, when he wants to lose electron in the outer shell, though 4s receive electron before 3d, but which one is the outermost shell? 4s or 3d? 4s and 3d.
Which one is what?
Which one is the outermost shell? Is it 4s or 3d? Outermost shell.
3d.
3d is on the third shell, girl.
Oh, so it's 4s.
It's on the fourth shell. So which one is the outermost shell?
The fourth.
4s. So 4s is what? Outermost shell. Am I right? Who loses electron first? The outermost shell. So electrons are lost from 4s before 3d. The electron are lost from where? From 4s before what? Before 3d. Is that okay? Know that. Therefore, the meaning is this. That's the last time I'll give you. I'll stop the class. Therefore, if you now have this, if they say this is ion is what? 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 4s2, 3d6. So what is now ion 2? Can you tell me what ion 2 is? So what? 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 3d6. 4s would have been lost. You get that now? Electrons are lost from 4 before 3d. What about ion 3 now? To lose 2 from 4s and 1 from 3d, now become what? 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 3d5. So, Tamunda, ion 2 and ion 3, which one will be more stable?
Between ion
2 and ion 3.
Ion 2 and ion 3.
Ion 3, d5 is symmetrical. Am I right? Is d5 not symmetrical? Is it not stable?
It's stable.
So this guy is symmetrical, so it will be stable. Do you agree?
Yes.
Why is ion 2 not stable? 3d6 is what? What do you call this guy? Electron pair repulsion. Do you agree to that? Others have 1, 1, 1. Only one has 2.
Yes, that one has 1 pair and others are 1, 1, 1.
Exactly. So ion 3 is not stable at all. Ion 3 is a green salt. If you pour it in water, leave it to under 10 minutes, turn brown. Right in your presence. It turns ion 3 on its own immediately. Ion 3 is not a stable salt. Ion 3 is the stable salt because electronically ion 3 is not stable. There is electron pair repulsion. You want to lose one electron and become ion 3. Is that okay?
Yes.
Does that make any sense? So the latter part of this is the only time I'm not touching on that this topic is ionization energy. It's in the note I'm sending to you. So read this up. If you have any question, we'll talk about it. Is that okay? So I'll send this right up, and I'll send the topical question and mass scheme. When you are solving your question, do not use mass scheme. When you finish solving everything, then go and sit down and mark yourself. You use the mark scheme.
Yes,
You must have answers to. You must have questions. So if you truly read it, you can't tell me you read everything and you understand. It's not possible. You come and ask me a question in the next class. We'll do it perfectly. Thank you so much. Bye bye.
Bye
So
bye.
yeah, bye bye. Yeah.
Tamuda, hope you had a great time today. Yeah.
Yes, sir. I did.
You know, I told you that I was just sending a message to your brother that when it comes to the A level, we are the best in the game. We're just quiet, and whatever we give is quality, and you've seen it first, and it's all across. It's all across the subject. It's all across. So this materials is going to be posted to the classroom today, on the
Okay.
Google Classroom, and the topics. We created it topic by topic so that when we put these materials, you're going to receive it, and then you can download it from your end. The textbook as well. He's going to get it. It's going to post on the Google Classroom so that you can start practicing and revising with it.